Okay, I just want to clear up a couple problems that I saw you guys were struggling with before you have to take a test on this. So these are all questions from week 2, talking about limits and then derivatives. So here, in this problem, we want to determine the end behavior of the following transcendental function by evaluating appropriate limits, then provide a simple sketch of the associated graph showing asymptotes if they exist. So the way they ask the question makes it sound like you have to do the limits first and then do the graph. But let's look at the graph because the graph will tell us the limits. So the parent function that we're looking at is natural log x. So let's think about, what does natural log of x look like generally? Well, generally, it's going to touch at 1, 0, and it's going to go up slowly and down kind of fast here, and it's got an asymptote that looks like this. So this blue graph here is just natural log of x, because that's our parent function. Now we're going to use transformations. So the first transformation we need to do is times it by negative. So that's going to change our y's from positive to negative. So all the y's which were positive will now be negative, and all the y's which were negative will now be positive. So this graph here is negative natural log of x. I use capitals in my natural logs because it makes it easier for me to read. I feel like when they're lowercase, it's hard to read. Okay, so now the last thing we need to do, is then add 3, right? This is positive 3. So adding 3 is going to move our graph up 3. So this point that I'm focusing on here, 1, 0, will go up to 1, 3, but the graph is not going to move left or right. So let's say that this is 3 here. So everything kind of moves up 3. So this orange graph is the graph of 3 minus the natural log of x. Okay, so now that we've got the graph, and I'm going to erase all the other ones because I don't really care about them. I really, only care about the orange graph final result. So now let's look at the limit of this function as x goes to infinity. Oh, I don't know why I'm having trouble drawing that. Oh, let's try that one more time. It's like I forgot how to draw it. Okay. So we want to know what's happening as x goes super far to the right. So we're going super far, and it's going to go lower and lower and lower and lower. It doesn't bend like that, but it's going to go lower slowly, but it still goes lower. So the limit as x goes to infinity is negative infinity. Now, what about the limit of the function as x goes towards 0 from the right, because it only comes from the right, doesn't come from both sides here. So my eyes are reading the graph this way, from right to left. Okay, that's where my eyes are going. So now I'm thinking, okay, where did that my eyes go? They went up, 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 up. So the limit as I come to infinity, as I come to 0 from the right is positive infinity. Okay, let's try the next problem. Okay, so let's try this problem here. We want to see if this graph is continuous. So this is a piecewise graph. It follows the pattern x squared plus 2x, but only for x is bigger than or equal to 1. And it follows the pattern 4 times x, but only for x is less than 1. So it's got two pieces. So if I was just looking at the green piece, that green piece is continuous, right? It's just a polynomial. And if I'm just looking at the blue piece is also continuous because, again, it's just a polynomial, in this case a line. So the only thing that we really need to consider is when x is 1. Okay, so if we come to 1 from the right, so we want to go towards 1 because, again, that's the only point that there could be a break. So, but we're going to come to it from the right, meaning from the bigger side. So let me put f of x here. So we're just going to consider the over here. So let's think about that. If we come to 1 from the right, we're looking at x values that are to the right of 1 but close. So let's do 1.1, 1.01, and 1.001. Okay, so those are getting closer and closer. We are going to have to use a calculator for this. So as we go towards 1 from the right, we have to use the green function to calculate. So we're going to do 1.1 squared plus 2 times 1.1. So I get my calculator out here. I'm going to do 1.1 squared plus 2 times 1.1, and I get 3.41. Okay, let's try 1.01. So to calculate that, I'll do 1.01 squared plus 2 times 1.01. So in my calculator, 1.01 squared plus 2 times 1.01. It's going to be 3.0401. And let's try something just even closer. Let's try 1.001. So we're going to do 1.001 squared plus 2 times 1.001. In our calculator, 1.001 squared plus 2 times 1.001, 3.00401. So as I come towards 1 from the right, using that green function, because those were all the x's to the right of 1, the function is getting closer and closer to 3. Let's try this same limit, but now let's go from the left. So let's take the limit of the function as x goes to 1 from the left side. So that's using the blue rules. So coming to x from the left side, or sorry, coming to 1 from the left side, let's use 0.9, 0.99, and 0.999. So those are getting closer and closer to 1 on the left-hand side. But now we have to use this rule for x. So 4 times 0.9, 4 times 0.9 will make 3.6. Okay, that's kind of close to 3. Let's see what happens when I put in 0.99. So 4 times 0.99. 3.96. Ooh, this is not looking good. 3.96. And then 4 times 0.999. We'll do that in our calculator. 4 times 0.999, 3.996. So I'm going to write 3.996. Oh, that doesn't feel so good, right? Because those numbers are getting closer and closer to 4. Wah, wah. What does that mean? Well, since the limit from the left does not equal the limit from the right, the limit at that value does not exist. So we can say that the limit of f of x as x goes to 1 in general does not exist. DNE does not exist. So now remember what I said. If I drew this picture, my green picture, x squared plus 2x for the x's to the right of 1 or equal to 1, those would all be continuous. That's a polynomial. It's a quadratic. And then on the left side of 1, 4x, that's another polynomial that draws a straight line. So we know that the function is not continuous at 1 because the limit does not exist. But on the right-hand side, it's continuous in its own section. And on the left-hand side, it's continuous in its own section. It's just where they don't meet up, so the whole thing isn't continuous in general. So where is the function continuous? Well, it's continuous for the x is less than 1, right? So from minus infinity to 1. And then it's also continuous for the x is bigger than or equal to 1. So from 1 to infinity. So really important here, do not use union. Use a comma. So now we finally get to go into the idea of a derivative. So here, first we'll talk about where it's not continuous. So I hope everyone can see that the fact that this happens here means the function is not continuous at x equals 2. So it's not continuous at x equals 2. But now, differentiable means that it doesn't have, it's like a smooth curve. It doesn't have any corners or breaks. So where would it not be differentiable? Well, it's definitely not differentiable at x equals 2 because there's a break, but it's also not differentiable here because there's a corner. So that's x equals 3. And now we have to sketch the graph of f prime. So let's just talk about that real quick. F prime is fancy for slope. Right, we defined f prime as the limit of f of x plus h minus f of x over h as h goes to 0. So it's really just a slope where the 2 points are closer and closer and close together, so close that it looks like the distance between them is 0. It looks like an instantaneous velocity. So let's think about the slope here. Slope is just going to be of a tangent line. So let's look at these 3 lines. What can you tell me about those 3 lines? Well, the slope of them is getting bigger, right? So from 0 to 2, I shouldn't say bigger, I should say steeper. So the slope is getting steeper. So what does that mean? It means your slope is getting larger, right? So steeper and steeper, it means more positive. Now, what's happening here in this next part? So think of this slope, and then this slope, and then this slope, and then this slope. So those slopes are negative, right? And they're getting more and more negative. So from 2 to 3, the slope is getting steeper. But negative. And now we can't actually do it at 3. So now let's look at the third portion here. We'll do it in pink. So the slope here, this is just a straight line. All of these slopes are the same. So from 3 to 5, the slope stays the same value. And I'll say that it's negative value. So our f prime, or our slope graph, is going to have 3 parts. The first part from 0 to 2, the slope is getting steeper. From 2 to 3, the slope is getting steeper but negative. And then from 3 to 5, the slope stays the same. So generally, I would say my slope is getting steeper, right? But we're going to use opens here because we're not including the edge. And then steeper but negative, so negative. And then it's staying constant, but still a negative value. So something like this. And you notice I didn't put like actual values on here, except I'll do the x's. So this was from 0 to 2, this was from 2 to 3, and this was from 3 to 5. But I didn't put values on the y because it's just a general idea of what that slope graph will look like. Okay, so now these last couple problems have to deal with derivatives as well. So we want to find the values of x where the slope of the curve is y equals f of x is 0, and the values of x for which the slope of the curve y equals f of x is 14. So the slope of the curve y equals f of x is fancy for derivative. So if our f of x is equal to x squared plus 10x plus 9, then f prime of x, which is the derivative of the function called x, will be 2x plus 10. So now, what part A is saying is, when is f prime of x equal to 0? Well, I could solve that, right? 2x plus 10 equals 0. So x equals negative 10 over 2, which is negative 5. So what values of x is the derivative 0? X equals negative 5. Let's do part B. So f prime of x, we want to find the values of x for which f prime of x is 14. So when is f prime of x 14? Well, I don't know, but I could solve that. 2x plus 10 equals 14. So 2x equals 4, and x equals 2. So when is the slope 14? When x equals 2. Okay, let's try one more. Very similar, little different. So let f of x be 2x cubed plus 3x squared minus 12x minus 6. And we want to find all the points on the graph of f of x at which the tangent line is horizontal. And then we want to find all the points on the graph of f of x at which the tangent line has slope 108. So speaking about the slope of the tangent line is just fancy for f prime of x. Remember, f prime of x is the slope of the function at one single point. It's called like an instantaneous slope. And since it only touches the function in one point, it's called tangent. So the tangent line's slope is the derivative of the function at that point. So let's look at our function. Our function is 2x cubed plus 3x squared minus 12x minus 6. So the derivative of 2x cubed, we're going to bring the 3 down and down. So we'll have 6x squared plus the derivative of 3x squared. So we're going to bring the 2 down and down. So I have 6x. And then this is x technically to the 1. So we bring the 1 down and down. And that would give us minus 12. Technically x to the 0, which is 1. And then here there's no x to work with, so the derivative of a constant is 0. So f prime of x is equal to 6x squared plus 6x minus 12. So now part A says, find all the points on the graph of f of x at which the tangent line is horizontal. So tangent line is horizontal means slope of the tangent is 0. And remember, to find the slope of the tangent, we're just looking at the derivative. So part A is asking, when is f prime of x equal to 0? Well, okay, I could solve that, right? 6x squared plus 6x minus 12 equals 0. I'm going to divide everything by 6. So I have x squared plus x minus 2 equals 0. And that I think I could factor into x plus 2, x minus 1. So double bubble equals 0. One of them had to be 0. So either x plus 2 is 0, meaning x is negative 2, and x minus 1 is 0, meaning x equals 1. But that's not my answer, because the question said find all the points. So the points are actually on this function, right? So I know that the x, when x is negative 2, the slope of that function on the tangent line will be 0. But what point is that? Well, I don't know. I have to go back and plug it in. So I'm going to find f of -2, which will be 2 times -2 cubed plus 3 times -2 squared minus 12 times -2 minus 6. So when x equals -2, let's find the y that goes with it. So that would be 2 times -8, so -16, plus 3 times 4, so plus 12, minus 12 times -2, so plus 24, and then minus 6. So I've got, see, 36, and then minus 22, which makes 14. So the location on the actual graph of f of x is -2, 14. But we also had x equals 1, so we're going to have to plug that guy in too. So x equals 1, we're going to go back to the original. F of 1 equals 2 times 1 cubed plus 3 times 1 squared minus 12 times 1 minus 6. So that makes 2 plus 3 minus 12 minus 6, or 5 minus 18, which is -13. So if I graph this function at the point 1, -13, that tangent line, the line that touches that graph only once, will have a slope of 0, or it will be horizontal. Okay, let's try the next part. Find all the points on the graph at which the tangent line has a slope of 108. So we have to find, we have to find part B here. We want to find the slope of the tangent line, so f prime of x, equals 108. Okay, but I know f prime of x, that was 6x squared plus 6x minus 12 equals 108. And now we need to solve, and this is a quadratic, so we generally want to get 0 on one side. So I'm going to subtract 108. So I have 6x squared plus 6x minus 120 equals 0. And again, all these are divisible by 6. So I'm just going to divide everything, even the 0, by 6. So I get x squared plus x minus 20 equals 0. And I know we can double bubble this into x plus 5, x minus 4. So either x plus 5 was equal to 0, meaning x equals -5, or x minus 4 equals 0, so x equals 4. So now again, those aren't the points, those are the x values of the points. So to find the actual points, we have to go back to the original function. So when x was equal to -5, f of -5 is going to be 2 times -5 cubed plus 3 times -5 squared minus 12 times -5 minus 6. So that's 2 times -125, right? 5 times 5 times 5. And then negative, negative, negative. So -125 times 2 is -250. Please use a calculator. And then negative 5 squared is 25, so times 3 would be 75. Minus 12 times minus 5 is positive 60, and then minus 6. So I've got 75 and 60, which is 135. And then I've got minus 250 and minus 6, so that's minus 256. So negative 121. So the location, negative 5, negative 121, that tangent line will have a slope of 108. And now I just need to find the other one. So we're going to go and we're going to plug in x equals 4. So I have f of 4 equals 2 times 4 cubed plus 3 times 4 squared minus 12 times 4 minus 6. So 4 cubed is 64 times 4 is 128. 4 squared is 16 times 3 is 48. Minus 12 times 4 is minus 48. Minus 6. Oh, that's nice. Plus 48 minus 48 is out. So I just have 128 minus 6, which is 122. So the location 4, 122 will have a slope, that tangent line will have a slope of 108. Here's that whole problem.